All right, these are going to be our notes on the activity series. This is page 13 of your packet, so if you're not on page 13, make sure you get here to be able to do the notes. So we're going to be starting off with some definitions at the top here of what exactly the activity series is. And this is going to be a list of elements ordered from most reactive to least reactive. Okay. And so that word reactive, the active part, we're talking about an activity happening. So when we say activity series, think about reactions, reactive. Ultimately, it's going to tell us, so it tells us if a reaction will occur. Okay. And we're going to be looking at a very simple type of reaction here called a single replacement reaction. So we've got AB plus C, and it's called single replacement because we're just swapping the B and the C here. So at the end of it, we'll have A is bonded with C, and then the B will be on the outside. So it's just two things switching places. These types of reactions will only occur if the lone element is more reactive than the similar element in the aqueous solution. So in this case, it's saying if C is more reactive than B, it's going to take its spot. You can think about A wants to be with C more because it's more attractive. So A will bond with C and kick B to the curb. Let's do an example of what I'm talking about here. So we've got the activity series written on our page. So this lists from the most reactive lithium at the top to the least reactive gold, AU, at the bottom. And so when we do a single replacement, we're going to look here and see what metals we're working with. In this case, it's going to be zinc versus copper. Okay. So zinc wants to replace copper, but it needs to be more reactive to be able to do that. So looking on the activity series here, we've got zinc kind of towards the middle area, right there. And then copper is actually way down here, towards the bottom. And so our lone element zinc is more reactive. It's higher up the chart. It's more attractive to the chlorine. And so chlorine is going to kick that copper to the curb. So we're going to get a Cu on the outside. And then in its place, we're just going to take this Cu that was there before, replace it with Zn for zinc. Okay. And so essentially we just took these two things and swapped their places. Example 2 gave away the answer a little bit, but let's look at why this is no reaction. Here we've got gold, or I'm sorry, not gold, silver, Ag, versus hydrogen. Okay. And hydrogen is way down here. It's actually just one step above copper. But even though it's pretty low, silver is even lower. So hydrogen versus silver, hydrogen is more reactive. And since it's already bonded there, silver is not attractive enough to kick out that hydrogen. So no reaction is going to occur because this is already a solid bond and bromine doesn't want to bond with silver over hydrogen. Okay. Let's move over to an example here. We've got zinc and nickel, so Zn and Ni. Let's see if this reaction is going to occur. We already found Zn, it's kind of towards the middle of our table here. And nickel is only 2 spots below it, but zinc is still higher. Zinc is going to be more reactive than nickel. So it is strong enough to do this reaction here. We're going to get ZnNO3, and then that nickel gets kicked to the outside. Okay. So what I want you guys to do is try these other 3 on your own, and then we will check our answer in just a minute here. So pause the video here, try it on your own, come back to check your answers. All right, go ahead and see how you did. The next 2 down did react, so you had to replace the metal. Aluminum replaced zinc, and magnesium replaced hydrogen. But that last one, no reaction occurred. And I'm realizing now this H needs a 2 on it because it's a diatomic atom. But yeah, no reaction on this bottom one because copper is not more reactive than lead. Copper is way down here, and lead is a couple of spots above it. So no reaction here. Okay, moving down to the single replacement of halogens. So halogens get their own little list. They're kind of in a league of their own. So we've got fluorine, chlorine, bromine, and iodine. And so we're going to use this list whenever we're working with halogens. So over here, we've got Cl is trying to replace bromine. And in this case, Cl is strong enough to do that. So it's going to kick out the bromine. So we'll get NaCl, and Br gets kicked out here. Now, all of our halogens are diatomic, so every single one of them needs to get a subscript of 2 when it gets kicked to the outside. So that's Br2. Okay. The next one down, example 4, is not going to react because chlorine is not going to be strong enough to kick out fluorine. Fluorine is like the top of the food chain. Nothing is going to be strong enough to break its bond. Okay, so let's do some halogen practice over here. We'll do the first example together, and then I'll have you try the other 3 on your own, just like before. So we've got fluorine wants to kick out bromine. And like we were saying over here, fluorine is the top, so it's going to win over everything. So fluorine will replace our bromine. We'll get LiF. And our bromine gets kicked to the outside. Okay. So with this example, go ahead and pause the video here. Try these other 3 on your own. All right, go ahead and check your answers. Just like last time, the 2 middle ones do react, and so we get a replacement there. But the last one, iodine is not strong enough to kick out chlorine, so no reaction is going to occur. The last thing we need to do is fill in some key ideas from these notes here. So if a metal is mixed with an aqueous solution containing another metal or the positive ion, which remember is the cation, that is the cation that is more reactive will bond to the anion. So whatever's higher up on our activity series is going to be the one sticking with the anion. And then our other key idea, when we have halogens, that halogen that is more reactive will bond to the cation, replacing the least reactive halogen. So that's the end of our notes for page 13. If you got confused on any of that, you can rewind the video and have me talk through the example again. But besides that, hope the practice goes well for this.